Good morning, everyone. My name is Timothy Lee Grant, and today I want to talk about why I am interested in artificial intelligence. So, I guess I should go back and talk about why I am interested in engineering in general. So, why did I choose engineering? One of the biggest reasons is because want to be useful, right? I want to be able to provide value to this society. And I looked around and I looked at, okay, which fields contribute most to human achievement. And I realized it's engineering. It's all engineering. So that's why I chose engineering. But then once I got into engineering, I said, okay, whatever I do within this field is acceptable, right? So I stopped worrying about money. I stopped worrying about anything. If you are within this engineering pathway, you're going to make money. You're not going to have to worry about being able to pay bills or not pay bills. If you graduate with an engineering degree and you have a specialty in a signal analysis in electrical engineering or fluid dynamics in mechanical engineering, or no matter which, if you go into chemical engineering, no matter what you specialize in, you're going to be able to make money, you're going to contribute to society. So once I got into engineering, I decided that I'm not going to look at what makes the most money, what I any of these things. I simply just let myself naturally go towards what I'm most drawn towards. And so I went into electrical engineering because I like more of the theory. I don't like necessarily the mechanical engineering, and I like the electrical. So I went into electrical, and then now electrical engineering is so broad. There's so many different fields. As I mentioned, there's signal analysis. There's actual power electronics, right? Getting the power to and from your house. There is semiconductor manufacturing. There is all of these different subfields. Assembly, computer engineering, like actually building the architecture of the processors and stuff like that. So there's so many different subfields, and once I got into my senior year, I'm starting to think like, man, what do I want to do? Because there's so much. And I realized that I like more of the theoretical. I really like math. I like programming. I like all of this conceptual theoretical stuff. I really liked my signal analysis classes because they were so math intensive. So I started thinking like, okay, what does that? And machine learning is heavily math focused. It's very math heavy. It's all like statistics, differential calculus, integral calculus, multivariable calculus. Obviously, you use linear algebra to represent the data as well. And machine learning is essentially taking all of the that theoretical mathematics that you learn and then applying it to a real world situation. And I really got a adrenaline rush essentially when I just finished my first machine learning assignment a few days ago, and when I would use all of those things that I've been learning for years and years and years, and I was able to take in data which had 8,000 entries with 83 different attributes. Each entry had 83 different attributes. I was able to take in that extremely large data set. Maybe not extremely large, but large data set, and I was able to make useful predictions on it. I was able to take something and actually create something of use, which was very inspiring. I really liked that. So that's why I'm getting more and more excited about machine learning the more that I do it, because now it's no longer, okay, just find the probability of a Bernoulli distributed event, go, right? So what's the probability of a call center getting a call within the next 15 minutes? Okay, well, you apply a Poisson distribution to it, and right? Like, it's interesting. As I said, I like math, but it doesn't have that use. And so that's finally what I'm getting at with machine learning, is that there's an applicable avenue for me to actually go towards it. And then the other thing that really draws me to it is that I really like the creativity and imaginative side. It's not something which is just following a formula. You really have to think about it. You have to analyze the data. You have to really try to conceptualize things and really think creatively. It's mathematics and art almost combined in a way, that you need to be able to dynamically think of problems and try to implement different solutions, whereas other fields, other specializations don't have this, right? If you're trying to find the gain of a circuit schematic, right? I mean, that's not there's not much avenue, or there's not much ability for you to have any creativity. It's just literally applying formulas. You have a formula for the gain which um, a certain block has, and you just apply your formulas, right? Same thing with other fields. Like if you are going into chip design, okay, you might be able to get a little bit creative of how you want to actually route your routers, but it's not anywhere near the level that artificial intelligence has. That you have to try to first find the problem, then think about what data you want to get in, think about which models you want to use for that data. Then, once you find that, you have to try to figure out which what is really the output that you're desired to get, and how to apply everything. And so there's that creative aspect as well that I don't see being applied in the other fields. And just talking about the other fields in general, right? There's not much other stuff that you can do once you learn it. And what I mean by this is, imagine if you learn like signal analysis. Let's just stick with signal analysis, I guess. You're going to be able to know how to communicate between a sender and a receiver, right? You're going to be able to really understand this process. You're going to be able to understand how to encode the data, how to sample the data at the Nyquist rate to make sure that you don't lose any information when digitizing. You're going to be able to do all of this, right? But what if you're interested in something else? Can you take that knowledge and apply it in a different field? What if you get really inspired to do something with biology? Can you do that? Right? Like it's not very applicable to other fields. You have to kind of stay within your domain. But what I'm seeing with machine learning is that this is absolutely not the case. That the better I get at machine learning, if I get inspired to do something else, I can use my machine learning to apply it to that field. I can go to work, do my job, and learn skills, and then come home and then use those exact same skills to apply to my hobby. How wonderful is that, right? How absolutely wonderful is that? And then the third thing is that I'm also very interested in kind of like the like philosophical and like psychological questions. I'm really drawn to that. I'm not just a math kind of person. I'm also really drawn to like philosophy and psychology. So I I think that I might be able to try to answer some questions that I have with machine learning. Yeah, like not just making art, but like understanding the under. Here's an example. Oh, this is actually a very good example. Okay, so here's a philosophical question. It's in the realm of aesthetics, right? Aesthetics is what beauty is essentially, like why people find something beautiful. So I'm interested in beauty, right? Okay, now how would I use machine learning to answer some of those questions? Okay, so not just making art. I don't want to just make art. I'm curious about what actually is beauty. What is the underlying cause of beauty? What is the underlying force which expresses itself in a piece of art, which expresses itself in a sunset, which expresses itself in these different individual instances? But what is the underlying substrata of that, which is beauty? What is that? Now, how might I go about investigating this? Okay, well, thinking about it is machine learning might be able to look at a wide variety of different images and instances which are classified as beauty, and then try to find some kind of underlying relationship which these images have. And by doing that, you might be able to start peeling back the layers and trying to find out more about this actual thing. So the instances would actually be data points, right? You would have as many data points as you want, and each of those instances are exactly what machine learning does, is take in a whole bunch of instances and try to abstract away and find the connections between these are classified as beauty, these are classified as not beautiful. What is the underlying relationship that these have that the other ones don't have? So that's just one of the many examples that I'm really interested in, and that's just an example as to why I'm interested in machine learning, because I'm able to take in all of these different other fields and use my skills to investigate the other ones as well. I'm able to actually investigate all of these very interesting, very uh, difficult ideas that people have been struggling with for a long time, and I'm just very interested in all of that. So that's the reason I'm interested in machine learning. I like math. I want to be useful to society, and I like that it allows me to go to different subfields, and also because I like the creative aspect of it, that I'm able to try to really, it's kind of like a puzzle. Okay, so that's why I'm interested in it. And if you want to know more about my journey towards machine learning, be sure to subscribe. And yeah, thank you. My name is Timothy Lee Grant, and I will see you later.